Hey class, sorry I couldn't be here today. I'm at that training, so I won't be in class today. This is going to be our video lesson for Unit 3, Day 4. So what we're going to look at today, yesterday we were talking about solving quadratic equations. Today we're going to talk about what happens when we solve it and our answers are imaginary. So what that means is we're using the quadratic formula. And what makes these solutions imaginary is that number underneath the square root sign is negative. Alright, so that number that we're going to call b squared minus 4ac. That number is negative, it means we're going to have imaginary solutions, so you can't take the square root of negative number. So the number we were just talking about, the b squared minus 4ac, that's called the determinant of the equation. Right, b squared minus 4ac is called the determinant. It determines what kind of solutions we have, whether we have two real solutions, one real solution, or two imaginary solutions. Alright, so there's basically three cases for what this number could be. First case is that it's positive. This is a positive number. All positive numbers have two square roots. They have a positive and a negative square root. Since this number would have two square roots, that would give us two real answers. So that's the first case. Second case is we plug in b squared minus 4ac from a quadratic equation, and it actually equals 0. It is 0. So 0 is pretty unique. It only has one square root. Square root of 0 is 0. In that case, we only have one real solution. In the third case is what we're going to be talking about. Mostly in this video, we look at that number b squared minus 4ac, and it's actually less than 0. It's negative. That number's negative, we're going to have no real answers. Or that's the same thing as saying we're going to have two imaginary answers. So how we use this is sometimes we see questions that are going to look like this. Determine the nature of the solutions to the following equation. Alright, so nature of the solutions. Alright, there's only three possible options when it asks this on a quadratic equation. It can either be two real, one real, or zero real. And zero real is the same thing as two imaginary. Alright, so anything that says determine the nature of solutions or describe the types of answers, anything along those lines, it's going to be asking you for one of these three options. So if you're taking taking a multiple choice test and there's a fourth option that doesn't match any of these, don't pick that option. There's only three options we can get here. So look at the first equation, 3x squared minus 4x plus 2 is 0. It's already in standard form. That's the important thing. If it's not in standard form, we have to put it in standard form, make sure one side is equal to 0. So here we have a is 3, b is a negative 4, c is 2. So we're going to check this number, b squared minus 4ac, see whether it's positive, 0, or negative. So b is negative 4, so I plug in negative 4 squared minus 4 times a is 3, times c is 2. That's going to be 16 minus 24. So that's going to be negative 8. Alright, since this is a negative number, there's going to be no real solutions. Or it's the same thing as saying two imaginary solutions. So we don't actually have to solve the equation when it says determine the nature of the solutions. All it's asking is what kind of solutions do you have? You don't have to actually go through and solve anything. You just have to answer this question. Is it two real, one real, or no real answers? So the second one's going to be about the same way. It's in standard form. So we pull off the A, B, and C are the coefficients. A, B, and C. And we're just going to plug them into that formula. B squared minus 4AC. So that'd be 1 squared minus 4 times 1 times negative 25. So 1 squared is 1. Negative 4 times 1 is negative 4. Times negative 25, that's negative times negative, which makes a positive 100. So we have 101. So that's a positive number. So that means I get two real solutions. So again, we don't have to actually solve this equation. We just have to say what types of answers we're going to get if the instructions say classify the nature of the solutions, or say what kind of solutions we're going to get. Last one, same idea. It's already in standard form, so we'll go ahead and look at A, B, and C. Plug them in, see what we get. So we have B squared minus 4AC. So negative 10 squared is 100. Negative 4 times 1 is negative 4 times 25. Negative 100. And that's going to be 0. 0. That means we get one real solution. Alright, so there's one of every type you'll see. No real solutions, which is the same as two imaginary solutions. So now you've seen how to do one of every type. You look at the worksheet you've got there, you should be able to do the first set now on your own. It says classify the nature of the solutions to each equation. So again, it means we don't have to solve these. Just have to say what kind of answers we're going to get if we did solve them. Is it two real? Is it two imaginary? Or is it one real? One thing to make sure of while you're doing these is make sure you're in standard form when you start out. This means you want to make sure that, like this one side is equal to 0. So you can pause the video here and work through these, or you can keep watching through the video until we get to the next thing, and go back at the end and do these. Next thing we're going to talk about is what happens when we do get these imaginary numbers. We have two imaginary answers. How do we work with those kind of numbers? So we need to work with what are called complex numbers. When we say complex numbers, this means all numbers, both real and imaginary. So the way complex numbers look is they have this form, A plus BI. So A and B are both real numbers. A is called the real part, and BI is called the imaginary part. And if you don't remember this from Math 3 or Math 2, this number I is called the imaginary unit. and what it represents is the square root of -1. Alright, since negative numbers don't have real square roots, we use these imaginary numbers to describe square roots for negative numbers. So we use this I, the imaginary square root of -1, to take us from the real numbers into the imaginary numbers. So the reason we work with these kind of numbers, these complex numbers where we have the real part, the imaginary part, is this what our answers would look like in using the quadratic formula. We kind of work it down and get an imaginary answer, two imaginary answers. Since we're always getting two answers, what we're always looking at is solutions that occur in what are called complex conjugate pairs. These conjugate pairs are formed by the plus and minus sign in the quadratic formula. So the idea is if a plus bi is one complex number, the complex conjugate would be a minus bi. So they have the same real part, but the opposite imaginary part. So a couple examples, if I had, let's say, 9 plus 4i, one complex number, the conjugate would be 9 minus 4i. If I had -3 minus 2i, the complex conjugate would be -3 plus 2i. So you have the same real part, but the opposite imaginary part. And that's true even if the real part is 0. So if I had 12i, the conjugate would be -12i. Alright, so all we're doing really is just changing the sign of the imaginary part. And again, where that comes from is the plus or minus in the quadratic formula. And the reason this is important, and we're spending all this time talking about complex conjugates, is solutions to quadratic equations always occur in these conjugate pairs. So if you know one solution that's imaginary, you automatically know the other. So I'll take you a couple examples of what this means. So it sounds very confusing, but what it means is actually something pretty easy. Since solutions always occur in complex conjugate pairs, if we know one solution, we know the other. So if 3 plus 6i is solution to quadratic equation, the other solution has to be the conjugate, which would be 3 minus 6i. Now you don't have to use any kind of formula or work backwards or plug anything in. All I have to do is change that sign. Since solutions always occur in conjugate pairs, we just have to find the conjugate. Same thing here. If 9 minus I is the solution to quadratic equation, what's the other solution? It'd be the conjugate, 9 plus I. So it sounds difficult because it has all these new words, these new vocabulary terms, but what it means is something very easy. They occur in complex conjugate pairs. If 9 minus I is one solution, the other one is 9 plus I. 3 minus 6i is one solution, the other solution is 3 plus 6i. So with that information, you can now do this practice part 2. So you're just giving the complex conjugate for each number below. So remember, we're taking the same real part and opposite imaginary part. Last piece for the notes here, again, what we're trying to do is build up all the skills we need to work with solutions to quadratic equations where we have imaginary answers, complex answers. So the last thing I talk about is how we simplify radicals. When I say radicals, I'm talking about is roots. So here's an example of simplifying a square root. Square root 48. So this number is not a perfect square. We can't take the square root of 48. We could take the square root of 49, that would be 7, but we can't take the square root of 48. There's still a way we can simplify this up. So what we do is we look for the factors of 48. So we have 1 and 48, 2 and 24, 3 and 16, 4 times 12, and then 6 times 8. And then what we do is we look through this list for perfect square factors. So 1, 16, and 4, these are all perfect squares. So what I want to do with these perfect square factors is take the largest one, largest perfect square factor, and use this to rewrite the square root, make it simpler using smaller numbers. So instead of square root 48, I'll write it as square root of 16 times 3. Right, so 16 times 3 is 48. Alright, then we're going to use something called the product rule for roots. It's basically just saying that the square root of a product is the same thing as the product of the square roots. So the square root of two numbers multiplied together is the same thing as the square roots of each of those numbers multiplied together. So what that means is I can actually split this into two square roots. Square root of 16, not 12, 16 times the square root of 3. And once I do that, I can simplify 16 since it is a perfect square. That's when we pulled that factor out to begin with. So square root of 16 is 4, and I still leave the square root of 3 in there. So this is now simplified. Instead of working with a big number like 48, I'm working with small numbers like 4 and 3. And sometimes we do this in the quadratic formula, we have things that'll simplify at the end to make our answers a lot more compact, and if we need decimals, a lot easier to put into the calculator. So last we'll do here is an example where we have the same idea but with imaginary numbers. So with imaginary numbers, we're going to do an example, square root negative 72. I know this is an imaginary number because it's the square root of a negative number. Right? There's no real number we can multiply by itself and get a negative. So that's how we know this is imaginary. So the first thing we do here, before we start listing out perfect square factors, the first thing we do is we get rid of this negative sign, we take it outside, and we make it the I, that imaginary unit. So it's kind of like we're removing that factor of negative 1, taking it outside the square root sign, and then working with the root on its own. And from here, we can do everything we did before. So we can list off perfect square factors. So 72, the biggest perfect square factor of 72 would be 36. 36 times 2 is 72. So from here I can rewrite it the same way I did on the last problem. The only difference, I'll have that I out front. So it'll be I square root 36 times 2. I'll split that square root. And the last step will be I'll take the square root of 36, which is 6, and just our convention, we usually write the number first and then the I. So 6I instead of I times 6, and the square root of 2 is still there. And again, the idea behind this is we want to make our answers as simple as possible. So if we get to this third sheet of the practice, where we're solving these equations, some of these you're going to have to use a quadratic formula. What you need to practice on these is simplify as much as possible. So you can finish up with the practice doing these where we're solving. Same thing we did yesterday, except now some of these are going to give you imaginary answers. If this video is not making any sense at all and you're not really sure what we just went over for the last 20 minutes, you can also just search up on Google um, quadratic equations with imaginary answers or imaginary roots. And you'll probably get a lot of things that are even more helpful than this. So keep working on this, work through the practice worksheet, and then you do have a homework assignment for tonight, which you should get from the substitute. If you have any questions about any of this stuff, I'll be back in class tomorrow, and you can ask them then.